The Megapack is a significantly more important invention. The Megapack is the answer to the biggest long-standing problem with green energy. For years, people always said wind and solar in any discussion about sustainable energy, but they were leaving out a critically important third side of the green energy triangle, which people now know is storage, because the sun doesn't always shine and the wind doesn't always blow, and that renders green energy unreliable at best and not particularly sustainable. So they need a way to store the energy and save it for later, which is a simple idea with a very complicated answer, because to do that you need batteries and a spectacular number of them. Then you need the inverters and cooling systems that make them work and keep them safe. You need to be able to do this at a price point that makes it all worthwhile. Tesla was the first company that was able to check all of those boxes with the Megapack, a product that is equally as important to the green energy revolution as the solar panel and the windmill. So let's get into some details on this unsung hero of the Tesla lineup. The simplest way to look at a Megapack is a box full of batteries. A power bank, the size of a shipping container, aside from the battery cells. Each unit has a liquid cooling system, the same as the battery pack in a Tesla vehicle. There's a bidirectional inverter to allow energy to flow in and out of the batteries, and an AC main breaker and controls. Tesla claims that the Megapack takes up 40% less space, uses a tenth of the parts, and can be assembled 10 times faster than other energy storage solutions. Tesla introduced the Megapack in 2019 with 3 megawatt hours of energy storage capacity, which is a staggering amount of energy in one box. The average Tesla vehicle battery pack, like the one in a Model Y, is 75 kilowatt hours of energy. There are 1,000 kilowatts in a megawatt, so 1 megawatt is equal to 40 Model Y worth of energy. Before solutions like the Megapack came about, the only way to deal with this problem was by using natural gas-fired peaker plants. When the demand for energy is about to overwhelm the supply, these peaker plants will kick on and start burning natural gas to generate more electricity for the grid. These peaker plants are very expensive, very inefficient, and very bad for the environment. Plus, they don't even work well because they need time to get up and running before they can reach peak output, so they aren't nimble enough to cope with sudden fluctuations in the energy supply. As of 2020, open-cycle gas turbines give an electricity cost of up to $200 per megawatt hour every time they are activated. Each Megapack with 300 megawatt hours of capacity costs about $1 million. Tesla's standard warranty covers that for 15 years, so that would be about $22,000 per megawatt hour per year, or about $60 per megawatt hour per day. So considerably cheaper and considerably better for the environment. And then when you consider that a peaker plant needs an entire giant building constructed with a staff to operate and maintain it, it needs to be linked in with a supply of methane gas, which first has to be extracted from the ground and then burned to create a few metric tons of CO2 as a byproduct. Or you could have a small field full of batteries that just sit there and function autonomously. The Megapack system is monitored and controlled by Tesla's autonomous software platform called PowerHub, so it doesn't require human oversight to function. The 10-year checkup is simply to replace the cooling pump and door gaskets. The total energy capacity is 730 megawatt hours, with a power output of up to 182 megawatts for up to 4 hours at a time during periods of high demand. Admittedly, it is a very delicate balancing act, and to make this work as a full-time energy source for a community of any decent size, it's going to require a lot of solar panels and a lot of Megapacks, but it can be done. The state of Hawaii is a great example of that. Hawaii already has a largest installed solar capacity per capita, and the islands plan to use 100% green energy as soon as the year 2045. By this September, Hawaii will have shuttered its last coal-burning power plant and replaced it with a large-scale installation of Tesla Megapacks. The Kapolei Energy Storage Facility will rank as one of the biggest battery systems in the world, with a capacity of 565 megawatt hours. Hawaii is taking things one step further by putting a new level of responsibility on their battery installation. The state says that the Tesla Megapack will function as something called a black start device, which can restart the island's electrical grid in the event of a natural disaster, operating kind of like a grid scale. There's already been a sneak peek into the future of the Megapack technology, which is basically just to get bigger and stronger. Tesla's website listing for the Megapack was recently updated with new specs, which did not coincide with any official announcement from the company about a new version of the Megapack. But the website shows us a larger, heavier, and more powerful product than the original launch in 2019. The energy capacity of the grid-scale battery is now at 3.9 megawatt hours, up from its original spec of 3 megawatt hours, and the weight also inquires by 64% to nearly. According to Tesla, shifting the Megapack to a dedicated production plant is going to allow for a significant increase in capacity. According to Tesla, right now they are able to make about 4 gigawatt hours worth of storage products per year in the Nevada factory. Still, the production target for the new California plant is said to be 40 gigawatt hours per year, and that's going to be thanks in a large part to new battery chemistry that will make it easier and cheaper to produce the Megapack. It's very likely that these new specs that people are seeing right now describe the Megapack storage system with lithium iron phosphate or LFP cells, its new battery chemistry, and Tesla, along with other electric vehicle manufacturers, have started using it for lower range cars with reduced performance. In addition, the cells don't use many of the high-cost metals that are typically associated with lithium-ion batteries, like nickel and cobalt. Instead, LFP cells use just lithium and iron in their cathode. The trade-off is a reduced energy density. The storage capacity per kilogram of cell material is about 25 to 30% lower in a vehicle. That's going to translate to a lower range and slower acceleration. But a Megapack does not move. In this case, Tesla went so much larger with a new Megapack that is actually exceeds the capacity of the older unit, even with the lower density battery cells. So what impact do you think the Megapack will have on our energy landscape? And have you seen one of these installations go up near you? Please let me know by leaving a comment below. And if you enjoy this video, please press the like button, turn on the notification bell, and subscribe to our channel for more videos like this. Thank you for stopping by to watch. See you in our next video.